I'm going to be talking about inductive and deductive reasoning. First off, let's talk about inductive reasoning. Okay, inductive reasoning is when you identify a pattern, you make a conjecture, your opinion, your guess, your hypothesis, and then you prove them true or false. So like we did the other day with exploration, we saw patterns, we made a conjecture, we made a conjecture, and then we made sure if it was true or false. We can especially do that with number patterns by using our calculator to make sure our conjecture is true. So if we look at the first sequence, 1, 4, 16, 64, I can make a conjecture that it's being multiplied by 4. So I can get my calculator out and go 1 times 4 is 4, 4 times 4 is 16, 16 times 4 is 64, and that works out. So I can continue on with the next two numbers. 64 times 4 is 256, and then 1024. We can do the same for the one on the bottom. 5 minus 2 is 3. 3 minus 2 is 1. 1 minus 2 is negative 1. Negative 1 minus 2 is a negative 3. And negative 3 minus 2 is a negative 5. Okay? Now we can do the same thing with number patterns or letter patterns. If we look at this A, C, E, G, we're skipping every other letter. We're skipping a letter. So we go A, skip B, C, skip D, E, skip F, G, skip H, then I, skip J, then K. So those are my next two. And if we look at the very last one, we have uppercase, going backwards, and lowercase going forwards. So we can assume that it's Z, Y, X, W, D, V, E, and those are next two in our pattern. So we can use inductive reasoning to identify patterns, make a conjecture, and then prove them true or false. Okay, so let's talk about a conjecture a little bit more. It is an unproven statement that is based on observation. So you can make a guess. It is your opinion. So we can make a conjecture to finish the sentence. It says the product of two not odd numbers is always, and I'm going to guess, odd. And let's see if this is right or wrong. 1 times 3 is 3. That's odd. 3 times 5 is 15. That's odd. 3 times 7 is 21. That's odd. So I've made a conjecture. I've proven it true. And that's using inductive reasoning. We can also prove a conjecture false by giving a counterexample. And all we need is one counterexample to prove a conjecture false. So our first conjecture says the quotient of two whole numbers is a whole number. Allow me to think of a whole number. 1 and 2. Those are two whole numbers. And the quotient means divide. So 1 divided by 2 is actually half. And 0.5 is not a whole number, so that is my counterexample of proving this conjecture false. Okay, let's do the next one. Conjecture, the sum of two numbers is always greater than the larger number. Well, if you think about it, most likely if we're using positive numbers, 10 plus 7 equals 17. 17 is larger than 10, so that works out. But it didn't say anything about negative numbers. So we actually can use negative numbers. So if we say something like 5 plus a negative 2 is going to give us 3, and 3 is definitely not larger than 5. So that's our counterexample proving that to be false. Let's move on to deductive reasoning. Now, deductive reasoning is what we use for geometric proofs in this class. This uses facts, definitions, accepted properties. Okay, so already proven true facts. Let's compare this to inductive reasoning. If we remember, inductive reasoning was a guess or an opinion. And deductive reasoning uses already known true facts. And deductive reasoning uses two laws of logic: syllogism and detachment. Okay. And I'm going to show you examples of syllogism and detachment and how we use them. Okay, so let's look at the first one. Let's look at the law of detachment. And my hint to you to kind of determine if we're using detachment or syllogism is that the law of detachment, I give you one if-then statement. So let's look at the first example. If two segments have the same length, then they are congruent. That's one if-then statement. So we're going to use our law of detachment to make a conclusion. Okay. The next piece says, you know that BC is equal to XY. We know that these lengths are the same. Well, if we know that these segment lengths are the same, then we can assume that they are congruent. So we can write down that BC is congruent to XY. So that's your law of detachment. I give you one if-then statement, and then you can make a conclusion about the fact that I give you. Okay. Let's see another example for the law of detachment. My first statement says, Mary goes to the movies every Friday and Saturday night. Then my next fact that I tell you is today is Friday. So what can we conclude? Mary is going to the movies. As simple as that. Let's look at the next one. If the measure of an angle is between 90 and 180 degrees, then the angle is obtuse. My next piece says the measure of an angle is 155 degrees, so we can conclude that the angle is obtuse. Right, and that's your law of detachment. I give you one statement, a fact, and then we can make a conclusion from that. Our next one is a law of syllogism. And the law of syllogism, I give you two if-then statements, and then we can write a new if-then conclusion from those two statements. And right now, the very first one is I'm showing you this with colors. If hypothesis P, then conclusion Q. If hypothesis Q, then conclusion R. If you notice, the conclusion of the first statement and the hypothesis of the second statement are both Q, they're both blue, that means they're both the same statement. So if we have both the same statement, it links those two statements together. We can omit those two that are the same, and we can conclude using the hypothesis from the first statement and the conclusion from the second statement. So I'm going to show you what this looks like with actual words. If Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. What can we conclude? Well, if we notice, Jesse will be Rick's lab partner has been repeated. So we can omit that piece and rewrite our new statement using the leftover material. If Rick takes chemistry this year, then Rick will get an A in chemistry. And that's our brand new conclusion. So I'm going to show you two more examples of this. Okay. So this is our law of syllogism again. I give you two if-then statements, and then we can write a new statement with our new information. So I say if Janelle gets a job, then she can afford a car. If Janelle can afford a car, then she will drive to school. So we can omit what's repeated. Then she can afford a car if Janelle can afford a car. And with our new information or our leftover information, we can write a conclusion. So we can say if Janelle gets a job, then she will drive to school. And that is our conclusion. Okay, let's look at our very last one using the law of syllogism. If you get an A or better on your math test, then you can go to the movies. If you go to the movies, then you can watch your favorite actor. Well, what we can omit what's repeated. And what's repeated is then you can go to the movies. And if you go to the movies. So we can write our conclusion using our leftover statements. If you get an A or better, on your math test, then you can watch your favorite actor. And that is your law of syllogism.